In this video, we shall look at how to perform integration of exponential functions. The basics is of course the following. If you have a function such as that, now a is a constant, so we know the integration of such a function is just 1 over a times the original function or the original integrand plus an integration constant. Let's look at this integral. How do we integrate that function 10 to the power x? The first step is to turn that 10 to the power x and write it in the form of an exponential function. So let's assume y is 10 to the power x. Let's take the natural log of both sides. So the left hand side is natural log of y. The right hand side is natural log of 10 to the power x, which is just x times natural log of 10. So now expressing y in terms of x, you simply get e to the power x times natural log of 10. So what we are integrating here is therefore e to the power x times natural log of 10 with respect to x. So remember, this is like integrating e to the power constant times x dx, which is 1 over a e to the power ax. So the above integral is just 1 over natural log of 10, because that is the constant a in this integral, times e to the power x natural log of 10. Since we know this is y and y is 10 to the power x, so let's rewrite that as 10 to the power x over natural log of 10, and you can certainly write an integration constant since this is an indefinite integral, and that's the answer. Now let's look at this integral, similar to the one that we did before. So again, let's assume y is 2 to the power 3 times x, so natural log of y is just 3x times natural log of 2. So y is just exponent to the power x times 3 natural log of 2. And we can write the above integral in that new form, e to the power x times 3 times natural log of 2 dx. Note, that's a constant, so upon integrating it, you get 1 over 3 natural log of 2 ex 3 natural log of 2, which we know is y, and y is just that. Substituting that, you get to the power 3x over 3 natural log of 2 plus an integration constant. Let's call that c. And that's the complete answer. What about this integral? So of course it has x and it has e to the power x squared, which is an exponential function. Upon close inspection, one can see that this is quite simply half of the derivative of x squared with respect to x. So let's use the method of substitution here. Let's equate x squared to u, like that. So that means the differential of u is just 2x dx. Upon substituting these results in h, we get x dx is half du, and e to the power x squared is simply e to the power u. And this is an easy integral to do. It's just half eu plus an integration constant c. And if you substitute back the expression for u, you get half e to the power x squared plus the integration constant c. What about this one? Again, when examining it, you see that the power of that exponential function is sine x, and the derivative of sine x is cosine x, which is the function multiplying that exponential function. So that would suggest the following substitution. The differential of w is just cosine x dx. So substituting these results inside the integral, j becomes e to the power w, cosine x dx is dw, and the answer is just e to the power w plus an integration constant, call it d. Putting back the expression for w, you get e to the power sine x plus the integration constant d, and that is the result. We have an integral of the same form here. So if you substitute tangent x as, let's say, u, du is just secant squared x dx. So your integral g will simply become e to the power u du, which is just eu plus an integration constant, say e. And substituting back the expression for u in terms of x, you get e to the power tangent x plus the integration constant e, and that's the final result. What about this one? Well, the denominator is a function that if you differentiate that function with respect to x, you get the numerator. So what you have, the integrand is in the form of this. So let's substitute w to be ex plus e to the power minus x. So that means dw is ex minus e to the power minus x dx. So substituting this information inside the integral, we get I as dw over w, which is just natural log of w plus an integration constant, let's call it d. Substituting the expression for w, you get e to the power x plus e to the power minus x plus that integration constant, and that's the answer. Now let's do this integral. It has an exponential function and also a trigonometrical function. So the best way to do this is by integrating by parts. As you can remember, we have to set a function for u and a function for v prime. So let's set u to be sine 2x and v prime to be e to the power minus x. So u prime is just 2 cosine 2x, and v is the result of integrating this with respect to x, and that is just minus e to the power minus x. So using the integration by parts formula, j becomes u times v, so that is minus e to the power x times sine 2x minus the integral of v times u prime. So v is minus e to the power minus x, so that minus will kill this minus, make it a plus. So it is e to the power minus x times 2 cosine 2x dx. You can write the 2 outside like that. Now we have to do one more time integration by parts for that integral. Let's call that integral g. So g is an integral of e to the power minus x cosine 2 times x dx. So again, let's set u, it is a new u, as cosine 2x. So that means your u prime is minus 2 sine 2x. Your v prime is e to the power minus x, and your v is minus e to the power minus x. So now that means g is u times a v, so u is this, v is that. So it's minus e to the power minus x times cosine 2x minus the integral of now u prime and v. So u prime is minus 2 sine 2x, so that minus will kill this minus, so it will make it a plus 2 sine 2x, and v is minus e to the power minus x dx, And you can bring this minus outside of the integral sign like that. Let's take the 2 out, and you get that. And immediately you notice that this integral is simply j, which is the original integral that you want to solve. So one can simply write it as 2j. Putting this result in here, because that entire thing is g, we get minus e to the power minus x cosine 2x minus 2j. Let's expand this a little. It's minus e to the power minus x sine 2x minus 2e to the power minus x cosine 2x minus a 4j. And one can solve j algebraically from this equation. So j is just 1 over 5 e to the power minus x sine 2x minus 2 to the power 2 times e to the power minus x cosine 2x. And that's the answer. You can add an integration constant e if you would like. One could even simplify this further a little by bringing the common term outside. So minus e to the power minus x over 5 times sine 2x plus 2 cosine 2x plus the integration constant e. And that solves the integral. Finally, let's look at this one. Again, we can do this by integrating by parts. Let's set u to be x squared. So that means u prime is 2x. V prime is e to the power x. So v is also e to the power x. So that means, according to the rule of integration by parts, I is u times v. So x squared e to the power x minus the integral of u prime times v. So that is 2x e to the power x dx. So now we have a new set of integral here. Let's call it j, for example. So j is the integral of x e to the power x dx. Again, we can use integration by parts. We can take, again, the new set of u and v, u to be the new u to be x. U prime is 1, v prime is e to the power x, and v is e to the power x. So I becomes x squared times e to the power x. I'm writing this line here. Minus 2. Now let's apply integration by parts. Integral j is u times v. The new u times the new v is x e to the power x minus an integral of new u prime and new v, which is e to the power x dx. So your final answer is x squared e to the power x minus 2x e to the power x plus 2 times e to the power x plus an integration constant, let's call it d. One could even simplify it a little. Take the exponential function out, you get e to the power x times x squared minus 2x plus 2 plus the integration constant d. And that's the final answer. Thanks for watching.